Dear students, welcome to my channel. Let's see the problem. Here the question is Z is a variable complex number. That means here in the Argand plane Z is a movable point. Let Z is equal to x plus iy. The next condition in the question is given modulus Z is equal to 2. That means modulus Z is equal to 2. This implies modulus Z means we see in previous class that modulus Z equal to x square, that means real part square plus imaginary part square. That means this is equal to 2. That means x square plus y square is equal to 2 square is equal to 4. Then show that the point z plus 1 by z lies on an ellipse. We first prove it. Now z plus 1 by z. This means x plus iy plus 1 by x plus iy. Now the conjugate of x plus iy means x minus iy. We multiply the numerator part by x minus iy, that is conjugate of x plus iy. Then we get x plus iy plus x minus iy, and denominator part is x square minus I square y square. That means here I means root over minus 1, that is I square is equal to minus 1. So x plus iy plus x minus iy by x square plus y square, that is x plus iy plus 1/4 of x minus iy. Here x square plus y square equal to 4. It is given in equation 1. So the result will be x plus 1/4 x, that means 5/4 of x plus I common, and y minus 1/4 of y, that means the result will be 5/4 x plus I 3/4 y. That means real part of z plus 1 by z is equal to 5/4 of x, and imaginary part of z plus 1 by z means 3/4 of y. Now we consider it as h and we consider it as k. So x is equal to 4h by 5 and y is equal to 4k by 3. That means x square plus y square equal to 4. The equation 1 gives. Equation 1 gives. That means our target is eliminate a x and y from the equation 1 and the parametric equation of the locus of the variable complex number z plus 1 by z. That means here x square plus y square equal to 4. This implies 4h by 5 square plus 4k by 3 its square is equal to 4. That means 16h square by 25 plus 16k square by 9 is equal to 16. That means h is equal to 4. That means 4h square by 25 plus 4k square by 9 is equal to 1. So h square by 5 by 2 square plus k square by 9 by 4, that means 3 by 2 square is equal to 1. It is the equation of ellipse. Now hence the locus, Hence the locus of h comma k is x square by 5 by 2 square plus y square by 3 by 2 square is equal to 1 is an ellipse. Comparing it with x square by a square plus y square by b square is equal to 1. A is equal to 5 by 2, b is equal to 3 by 2. So E is equal to root over 1 minus b square by a square. It is the formula of eccentricity. So root over 1 minus b square means 9 by 4. Here a square means 25 by 4. That means root over 1 minus 9 by 25. That means root over 16 by 25. That means 4 by 5. Hence the problem. Now we learn about polar form from Cartesian form of a complex number. Now here z is minus 1 plus I. It is in Cartesian form. Here it is the figure of the Cartesian form. Here real part is minus 1. That means if this is 1 then it is minus 1, and here the complex part or imaginary part is 1. That means here is 1. So the location of z is here. It is real axis and it is imaginary axis. So it is minus imaginary and it is minus real part. So we write z as this. Z is equal to r cos theta plus I sin theta. Then r cos theta is equal to minus 1 and r sin theta is equal to plus 1. So we divide r sin theta by r cos theta is equal to 1 by minus 1. That means minus 1. That is tan theta is equal to minus 1. See that here theta means this. Anti-clockwise direction. That means theta is equal to pi minus tan inverse 1. That means pi minus pi by 4. That is 3 pi by 4. So z is equal to r cos 3 pi by 4 plus I sin 3 pi by 4. Now r is equal to root over REZ square plus IMZ square. That means root over minus 1 square plus 1 square. That means root 2. So z is equal to minus 1 plus I is equal to root 2 cos 3 pi by 4 plus I sin 3 pi by 4. It can also be written as root 2 e to the power I 3 pi by 4. It is the irrational expression of z. Now we see the next problem. Here in the same pattern, r we get r cos theta is equal to 1, but r sin theta is equal to -1. So here tan theta will be -1, and in this case z1, position of z1 will be here, it is 1, and -1 means in this position. So here is the position of z1. So here the angle will be theta is equal to minus pi by 4. In fourth quadrant, the angle will be theta is equal to minus tan inverse 1. Theta is equal to minus pi by 4. So z is equal to minus pi by 4. Z is equal to modulus z cos minus pi by 4 plus I sin minus pi by 4. So modulus z means here also be root 2, because of modulus z, theta is equal to r is equal to modulus z is equal to 1 square plus minus 1 square, that it is also root 2. So here the answer will be root 2 cos minus pi by 4 plus I sin minus pi by 4. So root 2 e to the power I pi by 4 and negative root 2 e to the power minus I pi by 4. It will be the polar form from Cartesian form. See the second problem. Here, if we draw the equal angle in the first quadrant, it is the anti-clockwise direction, but here the angle is in anti-clockwise direction, and hence the angle will be negative. If it will be theta, then if it is theta, then it will be negative theta. So the angle is minus pi by 4. This is the reason of the angle become negative. Here note, theta is said a argument of the complex number, argument of the complex number, and denoted by arg z is equal to theta. Theta belongs to minus pi to pi. Then it is called principal argument. It is called principal argument. Principal argument. Very important note